Hello, this is Ron Kovach, Managing Editor of Building Operating Management Magazine. Thank you for attending today's webcast titled Repair, Recover, or Replace, Understanding Roofing Options. Our presenters today are Nick O'Hare and Christopher Kogan of Structure Tech Group, which is a consulting and construction services firm based in Kalamazoo, Michigan that specializes in the restoration of building envelopes, roofs, pavement, and concrete structures. Nick O'Hare is a quality manager for Structure Tech and has been involved with managing numerous building envelope and paving projects in the corporate, K-12, higher education, and healthcare industries. Nick focuses on understanding customers' needs and designing solutions to meet those needs. He prides himself on his commitment to achieving ultimate customer satisfaction and providing value through all Structure Tech programs. Mr. O'Hare is actively involved in IFMA, the Association of School Business Officials, the Association for Facilities Engineering, and the American Society for Healthcare Engineering. Our other presenter, Christopher Kogan, is a roofing manager with Structure Tech. Mr. Kogan has a Bachelor of Science in Construction Engineering and has been involved with Structure Tech since 2005. He's responsible for the management of projects ranging from evaluations and roof system design to preparation of contract documents and quality control procedures during construction. He is also experienced in steep and low-slope roof system technology. Today's learning objectives include: identify the factors that determine when a roof needs repair or replacement. Assess when a roof is at the end of its life. Learn how to repair and replace a roof system so that life cycle costs are minimized. Discuss how facility managers can be proactive in monitoring roof systems. Before we get started, I'd like to get a few housekeeping details out of the way. A live question and answer session will follow today's presentation. To submit questions, please use the Q&A panel on the right-hand side of your screen and send your questions to all panelists. Our presenters will answer as many questions as time permits. At the end of today's webcast, you'll receive a link to download a PDF copy of today's presentation slides. You'll also receive a link to a brief online assessment. Upon successful completion of the assessment, you'll get your CEU certificate. This webcast will also be archived at facilitiesnet.com/webcasts. And now, a brief word from our sponsor.
When selecting a roofing system, be sure to inquire about the performance history of the roofing membrane in climates just like yours. Ask for a list of projects with a track record in excess of 20 years. Sarnafil brand roofs have stood the test of time with installations in place for decades in every climate all over the world.
And with that, I'll turn it over to Christopher and Nick.
Good afternoon, everyone, and thank you so much for joining us today. I just can't tell you enough. This is Nick O'Hare, and I'm here with Chris Kogan, and we're just very excited to discuss such a timely topic here going into summer 2016. Chris, we're approaching the summer construction window, and people are wondering, you and I, Chris, we're getting asked this every single day, hey, what's the best approach? Can I repair these specific situations? Maybe is recovery a solid option for this, or does this roof need to be replaced since it's so leaking? So Chris and I's objective here today is to really help you to understand the different options and really everything that goes into it, the pros and the cons of each, and really educate you being facilities managers and facilities executives, in the different technologies, how to evaluate the roof systems, and ultimately how to make these decisions that are going to have the greatest impact and return on investment for your organization. So Chris and I, we have just a robust history with Trade Press Media Group and just the various conferences. NFMT in Baltimore, we've been there for the last 10 to 12 years, and just such a solid organization. And I think this is a timely topic, and thank you for that opportunity. But with so many different technologies, options, solutions that we're seeing in the roofing market, sometimes, Chris, it's almost like a matter of perspective, you know, on what's the best option. And if you've ever been to one of my presentations at NFMT conference or something like that, you know, I like to start with a joke, just to kind of break the ice. So this one's about a lawyer, and I'm not sure if anyone in the audience is a lawyer, and I have nothing personally against lawyers, but I can tell you they have a unique personality, and they have a unique outlook on things. So there's this one lawyer. He is just doing super well at his job. He's working his way up in the firm. I think he just made partner. So this guy decided to go out, buy himself a brand new Lexus, and he goes to the dealership, buys it, the thing is sweet. Decides he wants to get to the office. First thing on Monday morning, be the first guy there, so when all the junior partners and associates come up, they can see his brand new car, how well this guy's doing. So he parks next to the curb, very excited, gets the best spot, opens his door to get out of the door. All of a sudden, a rusted out pickup truck, Chris, flies by and takes the guy's door off, okay? Takes the door off of the brand new Lexus, and he's freaking out. He's screaming at the pickup truck driver saying, this car is never going to be the same. I just bought it. It's never going to be the same. Cop comes. He's screaming at the police officer saying, can you believe this guy? He took my door off. This car is never going to be the same. And finally, the officer says, sir, do you realize in the process of the pickup truck taking off your left door, you also lost your left arm? And the lawyer says, oh my gosh, where's my Rolex? So it's all about perspective. What's important to some people is not as important to others, and there's just a lot of options. So it can be a little bit about perspective, but me and Chris want to clear some things up, really bring it down to a condition analysis, letting the conditions dictate the recommendations for corrective action, whether it's repairing your roof systems, restoring your roof systems, replacing your roof systems, or potentially recovering your roof system. So what we have here is a common plant, you know, that you're dealing with if you're a facilities manager. So this is a high-end manufacturing plant. I'm sure a lot of you are in facilities like this. If you're in a school, you're responsible for managing, maintaining multiple buildings, multiple roof areas. Even in a healthcare environment, you have hundreds of roofs on these campuses, and these are going to really each have their own unique characteristics. Some of these roofs may be repaired, some of them need to be replaced, and some would be somewhere in between. And for the focus of this presentation, we are primarily going to focus in the low slope roofing environment. So we're going to look at what's typically referred to as flat roofing. We're not going to get into metal roofing. We're not going to get into shingle roofing, tile roofing. We're going to focus on the major low-slope roof systems in the marketplace. So first, to do that, let's just look at a typical roof configuration in this low-slope environment. So here we start with the deck. You know, in this configuration, we're looking at a steel deck. We have the insulation layer, which would then be secured to the deck via mechanical fasteners. Your secondary layer of insulation, and ultimately the roof membrane. This depiction is showing a multi-ply built-up roof system, and then your gravel top surface. So very common type of construction that we see in the commercial roofing marketplace. Just briefly on the basic types of roof system components. So we have deck types. You know, decking, Chris, oftentimes we're seeing metal decking, gypsum decking is common. You have Tectum or cementitious wood fiber, wood, precast concrete, poured-in-place concrete, lightweight concrete, a lot of different options and configurations there. If we're looking at common insulation types, you could have I would say the most common today is probably polyisocyanurate, wood fiber, perlite, fiberglass, EPS, fiberboard, number of different configurations there in the insulation market. And then membranes, I mean, this is really where we're going to get into it. So you've got single-ply membranes, multi-ply membranes, and some things that we really want to dig into now. So we're primarily going to focus on the three most common types of roof membranes in the commercial roofing marketplace. So we have built-up roofing systems being a major category. Within that, We have hot coal tar bitumen, which is really being phased out of the market. I think there's only one manufacturer or two potentially still in business today manufacturing hot coal tar bitumen. And your more common now today, your asphalt built-up roof systems. Multi-ply systems mopped in with the asphalt or coal tar and felt, and then typically coated with some sort of flood coat. Next, you would look at single-ply roofs. Very common today, we have elastomeric membranes, which would be your EPDM, ethylene, propylene, diene monomer, your black rubberized roofing, and then your thermoplastic membranes, which would be your PVCs and your TPOs. And then the last category that we're going to focus on are the modified bitumen roof, which you could have the APP, which is more of a plastic modified configuration, and the SBS rubber configuration. So good introduction of the three most common types of roof systems that we're going to see in the commercial roofing marketplace. Chris, could you give us an overview of just some pros and cons of the various systems?
Yep, and we'll go through the pros and cons of the actual different types of roofs. We won't get real specific on the subcategories like EPDM versus PVC. But typical pros and cons of a built-up roof system, you know, it's a real robust, abuse-tolerant system, ply redundancy, good fire resistance, it's a proven track record. We know it's gonna, it's gonna last a long time. Low life cycle cost. Cons, higher labor costs, and right now in this industry there's a shortage of labor. So that's one huge issue. Slower install, limited elongation. With built-ups, you're only looking at about 5% elongation as opposed to single plies, which can be excess of 100%. And then you have to have a lot of quality control inspections just due to the lack of the skilled labor that we're seeing in the industry.
And Chris, that's a great point. I mean, I think in the future, and we had a deep dialogue about this yesterday at a conference, built-up roofing seeming to become more of a specialized, going to be a specialty roof system, I think, in the future. High-performing roof system, but the trades really aren't getting into it as much now, so that's a really good point. What are some of the pros and cons, Chris, that we're seeing in the single-ply roof category?
So for single-plies, you've got, for the pros, you've got a low initial cost, quick installation. The membrane itself, it has good elongation properties, and you'll less odors during construction. It's not odor-free, but it's a lot less than a hot tar kettle sitting next to the building. The cons, low puncture resistance. So if this is a facility where there's a lot of foot-top or rooftop traffic, maybe you're running carts across the roof. Probably not the best system. And there's, with any roof, the seams are always the area of concern, and single plies rely on, their seam is the main waterproofing.
Good. And lastly, Chris, modified bitumens.
So this would be kind of an in-between of a single ply and a built-up. You've got factory surfacing and controlled thickness, so the rolls come out of the plant. You're limiting some of the install issues with the construction of a built-up roof because you have more factory controlled environment. It's more abuse tolerant, many install options, and you're going to have more redundancy. Usually these are installed at least with 2 plies, sometimes 3. Cons would be higher install costs, a little bit slower install. Same thing, labor shortage. It's going to take, you still have to have a more skilled labor force to do this type of roof than you would traditional single ply. Lap integrity, you do have more laps with this type of roof that are exposed, so that has to be taken into consideration. And then with torch down, for example, APP membrane, it's just the open flame on top of the roof, so that causes insurance concerns and just overall safety issues.
Yeah, so kind of a similar configuration to a built-up, and then you have that rolled, almost looks like a shingle cap sheet, the granulated cap sheet. So as far as life expectancy, what are we looking at?
Again, this is, you know, more on the roof system itself versus like an EPDM versus a PVC versus a TPO. But a built-up, you're looking at anywhere from 25 to 40 years. Single-ply for a fully adhered system, 18 to 25-year range is what you should expect to see. For a ballasted single-ply, 15 to 18 is typically what we would see. And again, on some of these, you know, if you put a ballasted roof, say, on an area that has no access, no foot traffic, you might exceed the 18 years. So mechanically attached, generally it's 10 to 15 years. And then modified bitumen, 18 to 25 years.
Good. And it's a range. These are the averages that we're seeing in the industry. Industry averages, like Chris said, they're outliers. We've dealt with ballasted EPDMs that are 25 years old, but the norm falls somewhere within these ranges. So having an understanding of the most common types of roof systems that we're going to be dealing with in our environments, in order to really determine what's the best solution as far as addressing roof problems, first we need to understand what are the conditions that we're going to experience within each of these different types of roof systems. And yet, in order to do that, you really need to evaluate your roof system. So Chris and I are going to go over a checklist, or some good points that when you're out there evaluating your roof systems, these are the things that you should really be looking at. So just to start, we always recommend doing an in-depth inspection of all drain assemblies to ensure that they're sealed and functioning properly. So Chris, we have an example here.
This would be an example of a good built-up drain flashing with a gravel guard around the perimeter. The flashings are coated. When checking the drains too, you definitely want to check the bolts. You lift the strainer cover off, check the bolts, make sure those are all tight, you know, make sure that it's not full of debris.
Yep. So for the most part, if you saw that on your building, you could be happy with the performance overall.
This, on the other hand, is what you don't want to see when you walk up on your roof. This is getting close to becoming a green roof. But yeah, this is definitely a drain that's either plugged down at the elbow or just, you know, it's accumulation of debris over the years, but something you would want to address immediately because this could be a potential, you know, you've got a lot of deflection in this area due to the amount of water, so.
Yep, and that could be creating a lot of issues. But just for clarity, Chris, this didn't earn any LEED certification points?
No.
No, okay. Okay, good, thank you. Thanks for the clarification. Next point in the evaluation is really doing the inspection of all rooftop projections, vents in HVAC units. So this one here, common detail that we see quite a bit. I think the intent was great. I think we have a LED flashing there that was wrapped around. I think due to a number of different reasons, number one, age, number two, application, we've got some clear deficiencies. You can see, tough with the lighting here, but we have a pen that's sticking clearly into a gap in the penetration. That's going to be an avenue for moisture to get in there. Chris, I think what we'd like to see is a nice stainless steel collar with a flange, you know, protruding. What do you think, a minimum of like 1 inch out of there, just to provide some really solid protection there. So that's a detail that could be breaking down prematurely and definitely could be causing a leak. On the other hand,
and here's an example of the detail we just discussed and how a good application or a good install would look. You've got a pipe projection with a sleeve and collar. Then also to the left of that, you have a pipe chase, is what we call it, but it's or doghouse, but it's instead of a pitch pan, for example, where you would build a box, run the pipe through it, and then fill it with sealant. This takes that and moves it up into the air off the roof. This is a lot better detail when you can install it. So that's what we always like to, you know, like to specify.
Good. In this?
Prime example of you know, just a piece of wood used for a pipe support. In this situation, it looks like we've got too much point loading on that blocking, and it's starting to sink down into the coal tar roof.
Yep. Okay. After that, we're going to perform an examination of all perimeter edge details to ensure that the fastening, the flashings, and reinforcements are properly accomplished. Very, very key here. I mean, 90% of the calls that Chris and his team get called into as far as leaks, roof deficiencies, most often than not, they're not problems in the field of the roof. Often it's at these transitions, terminations, projections through the roof. So what are the types of things we're going to look at here, Chris?
Yeah, for example, we're looking at a joint between two coping stones that's wide open, and you can see the staining on the brick that indicates that moisture's, getting down through. You always want to look at the top of the detail and then work your way down when you're doing an inspection, not just necessarily where the roof flashing itself stops.
Yep. What you would hate to do is invest a whole lot of money into that roof, which might not be your problem, when really the coping stone is the deficiency. You could have wrapped the coping stone and saved a whole lot of headache.
Here's an example of, it's not the best detail in the world. It's an embedded edge metal, and what happens here is the metal starts moving independently from the membrane, and it causes a split, especially with the built-up, because you don't have any elongation. Just not a good detail, and it results in a lot of maintenance.
Yeah. On the other hand, Chris, what would have been a better detail there?
We typically like to put in a free-floating fascia detail, which that allows the metal to move in unrestricted, basically.
Perfect. Thank you. Okay, and then this here, I've told this story a lot, and I've used this term quite a bit, but this is the architect's dream and the building owner's nightmare. This is the detail here. The architect, new construction designer, didn't want to ruin the aesthetic look of this corporate complex. So what they did is you can see that nice white metal coping coming down, covering the top there, but it didn't wrap down, and it left an exposed top of the brick, and you had deficiencies within the seals there at the coping interface. And it's clearly leaking. You're seeing staining every 10 to 12 feet. That's indicating that there's a big problem. Those bricks are taking in moisture. Those are going to create big problems downstream, and those are what need to be addressed.
Yeah, and one thing to note on this is one of those leaks where you may not notice it leaking into your building until the drywall feels damp. So you may have a seepage issue with this type of construction.
Yep, and you could be looking at mold, mildew, major requirements at that point. Okay, next in our evaluation, we're going to want to do an examination of the transition points, the flashings, counter flashings, expansion joints, et cetera, and just really a number of different things that we want to look at here.
So here we have a coal tar base flashing where it's a granulated modified sheet. However, it's starting to deteriorate right at the transition, and then we also have roof cement that was applied over the laps. It's also deteriorating, so something that should be addressed quickly as a preventative item. Here's an example of a base flashing lap that's open. So this is a direct point for moisture to enter the system, and this needs to be addressed immediately.
Now, if you see a detail like that, Chris, does that roof need to be replaced?
Not necessarily. This would be what we would consider strategic repairs, and you may end up having to reinforce the flat tie-in underneath the rock as well, for an example. But this can definitely be repaired.
Okay, good. And then here, we've got a sealant interface here near the roof system, just totally becoming unbonded, direct avenue for moisture to come in. If you're seeing things like this, really need to look at it because these are maintenance items. These potentially could be maintenance items, removing, replacing sealant, reestablishing the waterproofing integrity of the system as a whole, and getting some more life out of it. What we hate to see is you have leaks, and these could be problematic leaks that leak every single time they rain. So as a facilities director, building owner, you think if it's leaking every time it's rained, your roof is totally deficient, probably time for a replacement. What you'll see is you go up, you have problems like this, total maintenance issues, spend a few $1,000s, and you can get some really, really good life yet out of these systems. Now, Chris, this one here looks pretty good.
Yeah, we have a good, good base flashing detail. for the built-up roof, and we have a metal coping on top of the firewall there. The only problem is we have exposed brick between the two, and you know, brick is naturally porous, so moisture is entering that wall whether you see it or not, and potentially getting into the roof. So something like this, we would want to cover the brick, whether it be with metal rain screen or like a membrane.
Yep. You know, especially for a rooftop parapet, it's not going to have much aesthetic value, you know, covered up. But for the most part, it's a good detail. But like Chris said, could definitely be improved upon belt and suspenders style approach in maintaining the waterproofing integrity of the assembly. And then also, what we want to do is perform an overall inspection of the roof membrane to ensure proper application, installation, and overall integrity. And there's really 3 different ways we're going to talk about that, and we're going to look at some examples here. To perform that roof survey, you're going to do a physical condition evaluation, a core extraction to look at samples, testing, and ultimately a thermal imagery scan. So here we have coal tar built-up roof starting to show signs of aging. Chris, we call these raspberries, but really what is it? What's going on here?
This is basically with the coal tar, it has a very low melting point, so and in the wintertime what will happen is moisture will get down into the flood coat, and in the summertime it heats up that moisture and it basically boils and it turns into these tar boils. And it's kind of a natural aging process. Something like this we wouldn't really consider it a concern unless the gravel has become debonded from the plies, then we have problems.
Okay.
And this would be an example of a blister. And you know, isolated blisters are definitely things you'd want to address because they're either over time will result in dry felts and you know a leak point. So it's better to catch those early and repair them early.
Now you have a few of these candidates for repair. You have extreme blistering of the membrane. That's probably more of a replacement type scenario.
Yep, here we have a smooth surface built up. The surfacing on there is basically, we call this alligatoring, but the suns cause breakdown of the asphalt. So the plies need a surfacing. The roof system needs some kind of a reflective coating on there, keep UV off of it. So something like this, you know, you could do an emulsion coat and then like a nice aluminum coating, and you're going to extend the life of it. But this is a time where you want to address it. If you wait too long, the plies will begin to start wicking moisture into the system, and then we've lost that opportunity.
In this one here, we've seen examples like this, I mean, many of times, but it's severe ridging and wrinkling of a built-up roof membrane. This is indicative of the membrane being mopped in wet conditions, so trapped moisture between the plies, creating severe ridging, wrinkling of the membrane. Chris and I kind of like to tell a story. We had a technician here at Structure Tech. A guy had about 30 years roofing experience. He's the one that brought this job to our attention. His son had a soccer game on like a Saturday morning. The soccer game actually got rained out, and this guy had such a nose for roofing. He'd been in it so long. He knew someone was doing roofing in town. So on his way home from the soccer game, drives by the local school, sees the roofers just going crazy, mopping in these plies on a built-up roof, trying to get this job done, and brought it to the district's attention. District called out the contractor and said, hey, I hear you guys are putting these plies in wet, and what they said is, hey, no, it doesn't matter. The asphalt or coal tar goes down at such a high temperature, it's going to burn off any moisture in that system. You have nothing to worry about. 4 years later, Chris, we got a situation like this. So moral of the story is this is a sign of entrapped moisture between the plies, creating significant deficiencies. This is not a candidate for maintenance or restoration. You need to start looking at replacement there.
Okay, here's an example of a natural control joint in a built-up roof. As I stated earlier, they have limited elongation, so here's where it naturally happened. Probably a bad design. you need to put in a control joint about every 150 to 200 feet. So, you know, that's something that you could possibly repair this. It just depends on the integrity of the rest of the roof.
Okay.
Here's an example of a really old EPDM system. It's called the Mars attachment. But at the firewall there in between the two roofs, you have severe, we call it bridging, but it's inadequate securement of the membrane. We see this a lot on older EPDMs, older technology. Newer roofs will they require, it's called a reinforced securement strip, which keeps that from happening. It keeps the membrane will shrink over time, so it keeps it in place. So something like this could potentially be repaired, depending on the overall age and condition of the rest of the roof.
This here comes down to material type as well. So this is a first generation PVC. What we had is the PVC roof membranes, I mean, are like you would see the PVC pipes, you know, at Home Depot used for plumbing and all those different things, but they add a plasticizer to them to make them pliable, flexible. What was happening in these first generation PVCs is that the plasticizer would migrate out of the membrane, they would become embrittled, then you would have building movement and would see a shattering of the roof membrane, and that's what we're seeing here. You have something like that, you know, you're going to want to look at replacement over repair. PVC's high-performing roof systems now, they've really ironed those kinks out of them, and really one of the highest-performing single-ply roof systems on the market today, in our opinion. Chris, now this here is a situation, and we got involved in this, and I'm not sure, but I think this is the one where we found those dead roofers buried underneath the roof system here.
Correct. Those are tombstones right there.
Yeah, pretty bad here. We have an extreme lack of attention to detail in a retrofit environment. You know, we've got the unit there that was just totally sheeted over with the membrane, some very, very poor detailing at the drain assemblies, a number of different conditions here.
And also note how bad it ponds. Obviously, the drainage was not corrected during this install.
Yeah, so not a good example of a recovery or a retrofit situation. Not a roof that you're going to want to invest a lot into maintaining here at this point. And then next, we're going to want to look at core cutting. You know, we're going to do core cuts to look at, you know, what type of roof system are we looking at, and what's the condition and integrity of the components within the roof system.
This would be an example of a delaminated, built-up core cut, and this is telling us that we probably have entrapped moisture between the plies, and it could have been during install, or it could be just over time. And this is a well-laminated membrane, so this is one that's actually in fairly good shape and possibly could be restored down the road when needed.
Good. Okay. And then another thing we're going to do is just materials testing. So question we get asked all the time, I've got a built-up roof, is it coal tar, asphalt? Easiest way that we've been able to determine to tell is jar of mineral spirits, take a chunk of that bitumen, drop it in that jar, wait a minute. If it turns brown, you can be confident it's an asphalt built-up roof. If it turns green, that's going to tell you that it's a coal tar pitch roof. Very, very important to know, because if you're going to restore or repair these roofs, you need to be sure that you're using compatible materials. So core cuts and destructive testing are very important. And also important is the infrared structure scan survey. And Chris, I don't think this was you and your team last night. This might be a little bit older, but I don't think they make cameras like this anymore.
No, and I'm surprised this picture is actually in color.
Okay, so we've got a team here using a very old infrared camera. Now they've got some very high-end, high-quality infrared thermography cameras, handheld units, and you're going to walk the surface of the roof. And what you're looking for is heat and temperature differentials within the roof system. And what that's going to tell you is if you have substrate conditions, really wet insulation is what you're looking for. So here we have some examples of wet insulation entrapped within the roof system. That orange and yellow coloring, that's coming out around 60 degrees. The cooler is more around 45, so we're sensing these heat differentials seeing the amount of wet insulation present within the system. And that's going to tell us where a lot of our problematic areas are and direct us to the right course of action. So having said all of that, we really gave an overview of the most common types of roof systems that we're going to see in the commercial roofing marketplace. We gave an overview of how to evaluate these types of roof systems. To get to this point, what you need to do when managing a complex facility portfolio and looking at what's the right course of action for you in a remedial scenario, you need to develop a solid roof asset management program that's developed on a solid roof condition index, and really use that to drive your 3 to 4 pronged approach, whether that's replacement being one prong, restoration being another, repair being another, and recovery being that 4th prong. So the roof condition indices, and if you're interested, we could get you a copy of this. Just good reference. I'm sure if you ask the team, Wendy and the team at Trade Press, they'll get us connected, and we'll get you this data and some other really, really good backup data to support that. But this is a roof condition indices rating. Easiest way for me to describe it, 0 is failed, 100 is excellent. Anything in the 0 to 30 range is going to fall into that roof replacement camp. Those patients are dead. Don't do surgery on those patients. Those patients need to be, those roofs need to be replaced, okay? On the other end of the spectrum, your 70s to 100s, those roofs are in great shape. Even if you have leaks, which you shouldn't have a whole lot, but if you have a leak, go out there and do the repairs. Do your preventative maintenance program and keep these good roofs in good shape and let them live out the rest of their lives. And in the middle there, we have roof restoration. You're looking at roofs that are at the midpoint of their life. You catch them while they're between a 50 and a 70 on the condition index rating, and you invest into them, and you bring them back up to 85s, 90s, and you double the life of the existing roof. Big impact there. And then 4th, we want to look at retrofitting and recovering. Could be a great application for sure, but we're going to look at that very selectively, looking at overall life cycle cost of ownership, looking at applications where it could be a really good fit for you. So that's that 4-pronged approach that we're going to look at for an asset management program. So looking at each one of these categories in a more in-depth overlook, Chris, we have roof replacement. A number of different options for roof replacement. We could go with single-ply systems. We could go with built-up roof systems. We could go with mod-bit roof systems. It's going to be what's the best fit for you in that specific environment for your specific building. The big thing that we need to look at is detailing for a successful project. Chris gave the overview of you could have a built-up roof that will last 20 years, or you could have a built-up roof that will last 40 years. You could have a single-ply that's going to last 10 years. You could have a single-ply that's going to last 20 years. All comes down to detailing. So really, we recommend taking a critical look at the detailing. And when you're replacing, these are typically major capital expenditures. And you're going to have to bid that out to 3, 4, 5 contractors to get that competitive pricing. To do that, we recommend preparing a very, very tight specification that lays out exactly what it is you're looking for. And I would recommend looking into the CSI format for specification writing and the AIA contract documentation, and really taking a look at that and trying to incorporate that into your next roof replacement project. But there's very specific parts on where you put the products that you're going to specify, and ultimately the execution. And Chris, let's just take a look at a common detail of what we're seeing out there that most roofing contractors will utilize, and how we might want to improve on that in a replacement scenario.
Okay, so this is an example of a base flashing detail for a built-up roof. It's flashing termination. You can see there's a termination bar mechanically fastening the top of the base flashing to the vertical substrate, and then they run a bead of sealant across the top of that. That detail is acceptable for manufacturers for various warranty durations. However, that sealant is going to be the first weak point, and it essentially relies on sealant to keep the moisture out. So
What's the lifespan of a typical sealant?
I'd say 10 years if you're lucky.
And you want a 20-year roof, and you're relying on a 10-year, watertight system.
So here's an example then of what we like to promote is a secondary counterflashing over top of the primary seal. That one may also rely on sealant, but 10 years down the road, if that sealant splits and leaks, you're only leaking through the secondary flashing.
Okay. And Chris, in a competitively bid environment, are you going to see much of a cost on that?
No.
Okay, good.
And one thing to note too, with putting a concise document together, you're ensuring that all the bidders are bidding it the same way. Whereas if you're just relying on proposals, you may not know that that's included versus somebody else may just have the termination bar included.
Exactly. And typically we see decision-making factors in this order when it comes to replacing a roof. Typically, price is that first decision-making factor. We're looking for a low price. A high value is placed on roof warranties, and unfortunately, quality of the application and system chosen tends to be last. What Chris and I like to see is quality elevated to that number one standpoint. You're making these major investments. You need a system that's going to perform. Price is always going to be important, and you need to keep price, at the forefront. So we recommend price being that number two decision-making factor, and ultimately warranty being three. We recommend warranties. We love roof warranties, but Chris, the problem we see with them, are they always written to protect the owner?
No, they're written to protect the manufacturer. From what I've seen, very rarely is there a situation where the product itself has failed. You do see that on occasion, but most of the products on the market today are, they've been tested and they've been around for a while, especially in the ones that we would spec. So it's really, where it comes down to the labor and the install is where you're going to have the problem.
Yep, of course. So lastly, looking at your options for replacement, you need to do a life cycle cost analysis. I mean, does it make sense to invest $100,000 on a 10-year roof or $150 on a 20-year roof? Really make sure that you're making the best use of the life cycle cost of ownership of these facilities and looking at more than just that first cost.
Yep, yeah, you definitely want to take like a common year for this. For example, the 10-year roof, you would replace it 10 times in 100 years versus a 25-year roof, you replace it 4 times. So that's how you have to look at a true analysis of the type of roof you'd want to go with.
So good overview of roof replacements, the considerations to look at there. And these are at roofs that are 0 to 30 in that roof condition index rating. They have foregone their useful service life. These are roofs that you do not want to repair. These are those replacements. Now looking at roof restoration. Restoration is a hot topic in the industry, great technology, where it's a candidate. So the objective is to double the life of the existing roof system for 1/4 to 1/3 of the cost of a full replacement. Chris, that can be some pretty big impact on a budget. If you're looking at a 10 million square foot complex, you can invest 20% of the cost of replacement and double the life of your roof. You're going to see some pretty big savings there.
Yep, and a lot of times too with restorations, they come out of a different budget fund. Like you don't have to use capital dollars. You can use maintenance dollars.
Yep. Good. So, Chris, can you just give us an overview of the different means, methods, and procedures for restoring roofs for each category?
Yeah, for a built-up smooth surface asphalt, you could do an emulsion coating, or a gravelled roof, you could do a resaturant, and the same thing would apply to a coal tar. Modifieds would be similar to a smooth surface asphalt. You would want to do some type of a coating on that. Those coatings can vary. Single ply is pretty much a coating, and there's a lot of different coating options out there in the market now. We like to specify the ones that have been around a little bit longer. But you see a lot of different coatings.
We're looking for tried and proven, minimum 10 years more, proven performance in the industry. So we've got our example here of that smooth surface built up that was starting to show signs of aging. What would we do here, Chris?
We would do an emulsion coating with in this situation, emulsion coating with a reflective aluminum coating on top.
Yep. Yep, double the life of that roof.
And basically restoring the surfacing of it.
Conditions, typical of a coal tar built-up roof.
Here, in the previous slide, we were seeing exposed felts, and here is part of the restoration process. You definitely want to do an infrared survey and remove any wet insulation. Afterwards, new gravel, sweep it new gravel, resaturant coating, generally new flashings, and you've got a good, a good roof for a long time.
Yep. This here, great example of a protective, aluminized coating over a modified bit roof. Roof, I think, right at the midpoint. We were involved in this project last summer, right at the midpoint of its life. Owner was having some leaks, some conditions. An assessment was completed, determined that, the roof itself wasn't in terrible shape, and it didn't need to be replaced. So the flashings were redone, came out with this nice high-end aluminum coating, coated it, and the owner's anticipating another 12 to 15 years of life out of that roof. And it might need to be coated again throughout, but really protecting that roof, restoring that roof at a minimal cost. And that's really the benefit of roof restoration, if done properly on the right roof.
And then we get into repairs. I like to say strategic repairs are items that we want to fix now that are going to be a little bit more costly than your preventative items, and they may or may not go along with restoration. But for example, this is a single ply where we're going to reinforce all the laps with an overlay strip, cover tape, and done selectively. It's definitely a good investment.
Yep. And that's just another kind of detail.
And so basically have details we put together for even repair projects.
And after that, might you come back with the coating on a single ply?
You could.
Good. Okay, and then next let's look at roof repairs. We broke that down into two categories. Number one being preventative maintenance, number two being repairs. We want to focus on preventative maintenance. So again, this is another thing. We could do a whole hour on preventative maintenance, the importance of preventative maintenance. You don't go out and buy a new car and never change the oil, never give it a tune-up. Don't spend $1 million on a roof and never do preventative maintenance. So we've got some really good write-ups and stuff, and again, we could get you that data should you request through the Trade Press team. But should be completed really twice a year at a minimum, spring and fall. What you're looking to do is extend the life of your assets through predictable maintenance, saves on the overall life cycle, and really is very preventative in nature. On the other hand, we have repairs. Repairs, we're going to say, are more reactive in nature. You're responding to leaks. Typically, those are more costly in nature, and often Band-Aid style approaches are being completed for repairs. Really, what you should do if you have a roof that's in that 0 to 30 range, you want to invest minimally until a roof can be fully replaced. You got those 70 to 100 range. Yeah, do your preventative maintenance, do your repairs where required, but just selectively invest into these roofs. And then lastly, Chris, we definitely want to talk about roof recovering and roof retrofitting. It's out there in the industry. A lot of people have done it with good success, for sure. Others have not as well, but we just want to look at some real selective applications where it might be a good fit. I think the big thing here, Chris, is we need to look at overall life cycle cost analysis. Does it make sense to make these investments if you're going to be in these buildings for a long period of time, and ultimately risk mitigation? What are some considerations for retrofitting?
To do it properly, you're going to want to make sure the substrate has no wet insulation, it's dry, it's acceptable. There's only one roof on it currently. A lot of times you'll see two roofs and somebody wants to install a third. That's a code violation. And then just paying attention to the detailing like you would a full install. Again, it's the detailing that's going to fail generally first. So.
Yeah, I mean the sad thing, Chris and his team get called out on failures of roof systems quite often, and what we see is you know, these retrofit applications are often done very inexpensive, cheap, lack of attention to detail. And the owners are getting less expensive pricing on it, obviously, than replacement. You're saving on the cost there, but could be great applications on short-term hold buildings. You don't want to do these on your high-end facilities that you want to have in the portfolio for the next 30, 40, 50 years, just because it's going to potentially put you at risk in some scenarios, and you're going to have to replace that roof in a much shorter time period than if you were to invest a little bit more, do the full replacement, and get a very solid, high-end roof that's going to last you for a long time. But there's a place for it, and we recommend it in very selective applications as well. And then just some more preventative maintenance tips that we'll look at. You want to go out, remove all debris. You want to clean out the drains. You want to inspect the roof surfaces. You want to inspect all the projections and penetrations. Evaluate the rooftop perimeters. Inspect the conditions of the sealants. Really review the underside of the roof. What would you be looking at the underside of the roof, Chris?
Signs of deteriorated decking. That may indicate that you have entrapped moisture in your system. Mm-hmm. You may not see it leaking.
Yep. Good. And the objective is to prevent roof leaks before they start. And then, you know, look at applications for additional investigation. So I think, you know, that wraps it up for the presentation standpoint. You know, it was just a lot of fun, a lot of really good information that Chris shared, and we just hope everyone got a lot of value out of it. And we'd just like to open it up for some questions. We'll answer as many as we can now. I know the Trade Press team has a number of questions that have come in. We'll take some time to answer any questions. Hook up with Trade Press. They'll get you either to Chris or I. We'll answer any questions under separate cover as required.
Okay, excellent presentation. We do have a number of good questions in from our national audience. Let's start with the first one that relates to retrofitting. You say retrofitting is only good if done selectively, and yet don't we have manufacturers these days offering a lot of 20-year warranties? Can you speak to that issue?
That's a really good question. I appreciate you answering that because we hit this all the time. And it's tough. So the materials used carry that warranty, okay? They carry that 20-year warranty, and it's called the system warranty. The fact of the matter is 90 to 95% of the retrofit roof failures that Chris and his teams get into are due to issues with the substrate. It's wet insulation. It's deck deficiencies. A number of different things that happen on the original roof system that this retrofit was installed over that end up creating problems on your newly retrofitted system, and the manufacturer won't warrant that. And that's a tough situation because typically the sheet that it was overlaid with won't fail prematurely, but the system itself will fail, and the owner's left with a short-term scenario. They were hoping for 20 years. You get 7 to 10 to 12, and it just leaves the owners with a little bit of heartburn. So great application if the proper attention to detail is taken and you know what you're getting yourself into. I don't ever want to steer anyone away from that. Always. It's just very selective in these situations that you're using it in. So that's a great question. Thank you for asking. All
right. Here's a pretty straightforward question that a lot of facility managers perhaps wonder about at times. How much water ponding on a roof is bad?
I would say any water that remains after 48 hours after a rain is considered ponding, and anything that would be over a half inch or so deep would be bad.
And what's that going to cause, Chris?
You're going to start causing deck deflection possibly. You're going to compress your insulation, and generally what happens is that starts propagating over time. So, you know, you just really want to kind of pay attention to You know, being that we're dealing with a low slope roof, you know, it's not going to drain real fast. You just want to be paying attention to when it had rain last and kind of make that determination, but that's generally what we like to go by.
Yep. And also advanced UV exposure, which is tough on roofs, and roofs aren't meant to hold water either. You want to get the water off the roof, so like Chris said.
All right, another question. Can you restore an IRMA roof?
You probably could, but you're talking a lot of labor to remove the overburden. And then a lot of cleaning preparation work on the membrane below it. I would hesitate to say it would work real well. You know, you're talking, you know, IRMAs are generally, the membrane are exposed to water at all times, so. Like Chris said, you probably can, but you have to look at, there's a law of diminishing returns here too. Is it going to be too costly to remove the overburden, get that roof cleaned to a point where you could perform the restorative work and then restore the overburden and get that roof, you know, back to its time? And what's that investment versus the investment in replacing? And you want to look at that and see if, you know, if it's worth that investment. But if you really wanted to, like Chris is saying, there might be some things you could do. In a situation like that, it may be more cost-effective just to, at that point, replace the membrane and start over if you wanted to keep the IRMA.
All right. All right, another question. Do you recommend using aluminum non-fibered or fibered asphalt roof coatings on flat roofs as a standard maintenance sealing practice?
I would say, I mean, either way, you're looking for the reflectivity. You're keeping the UV off of the membrane. I think the fibrated coating is going to help it. It's probably going to make it last a little bit longer, just based on the. It's going to give it a little more strength from expansion and contraction.
All right. Another listener writes, please clarify your maintenance suggestion on using an emulsion coating first and then using an aluminum coating for a two-coat process.
Typically, the emulsion would be done first. It's basically you're building your flood coat back up, and then the aluminum coating is the coating that will go over top of that, which is your UV protection.
All right. Is there a reason that ballasting or mechanically securing a single-ply roof lowers its life?
Yeah, I mean, and Chris can elaborate on this. I can tell you, number one, just with ballast is, ballast is up there and it's aging as the roof ages. I mean, Chris, me and you have been up on roofs that are 10 to 12 years old. You start walking on that ballast, it weathers, it shales, it cracks, it fractures, and you have a potential to puncture your roof, with the ballast being one.
Yeah, and the thing with the ballast is there's really nothing mechanically holding the roof down, so it's susceptible to wind damage. That's the main thing. I know FM doesn't really like to see ballasted roofs. I don't think they have any assembly numbers, you know, factory mutual. Mechanically attached, you're basically, I mean, there's certain places for it, but you're putting a lot of point loading on the membrane, on the fasteners. Over time, wind loads are going to start pulling at the fasteners. That's the biggest thing on these systems is the wind. You know, just making sure you have the right roof designed, and then certain roofs are going to hold up better, say, in a hailstorm. Like a mechanically attached roof isn't going to do very good compared to, like, say, a fully adhered over a hard substrate like a gypboard.
That's one of the number one causes of failure in single-ply systems, is that fastener back out that Chris was referring to, just to the different stresses that these roofs are under throughout their lives. You know, those fasteners start working, they eventually back out, roof becomes disengaged and creates a lot of problems.
All right, our next question relates to solar. The listener wonders, how should a customer manage a roofing installation warranty with a solar panel system installation warranty, especially concerning all roof penetrations?
Well, fantastic question. A lot of variables there, so I'll try to be as direct as possible, but number one, is it a new roof being installed while the panels are being installed, or is it an existing roof that you have in place, now you're bringing back solar panels? That's going to be two different applications. The first one, you can really design for it and design for those penetrations. The second one is going to be a costly approach, and you really need to evaluate the integrity of that existing roof system, because what you're going to have and what you don't want to face is put these solar units on top of the roof that only has another 3 to 5 years left in it. It's going to be an expensive tear-off and replacement, and you're going to have a lot of leakage at those penetrations. So the minimal amount of penetrations you could put in a roof, the better you're off going to be. But if you're doing a new design install, I think you're going to be in a better spot. But still, when it comes time to maintaining and replacing that roof, it's going to be a more expensive proposition for sure. But you just want to make sure that it's flashed and designed properly to accommodate all those penetrations. Well, that's a great question, and a lot of people are facing that exact same scenario as solar and alternative energy sources become more prevalent in the industry.
All right. Are there master specs that can be used as a guide for the three-prong roof repair, replace, restore criteria?
Yes, yeah, we actually have master specs for all three different applications and details. I know a lot of the roof manufacturers will they also have a good spec, like you could use like a good baseline spec, and if you talk to some more of the repair manufacturers, like say a Karnak or I'm trying to think of a few other ones here, but they'll have some good good specs.
Yeah, in the major manufacturers, the Sarnafils and all the high-end, material manufacturers are going to have baseline specs for sure that are a great starting point. What Chris was getting to on those detailing, there's things you can do to really enhance those as well to get some further life, but those are a good starting point, and I guess we could get anyone some more data on that if they should require just a little bit more in-depth under separate cover.
Okay. This listener wonders, how do I figure out if the water dripping inside a room is due to a roof leak or condensation inside?
Well, typically what you'd want to do in that situation, we call it like a leak evaluation, but you want to isolate the components in the area and introduce water to it and do actually a leak testing and make it leak. So if you isolate all the different components, spray it for a while, you get no leaks, then it's probably a condensation issue. That's typically how we would handle it. I mean, we've done that on exterior, we've done that around units, roofs. That's generally the best way to do it. You've got to systematically water test it.
All right. And we have a listener who says, our school division has 55 buildings and over 98% of our roofs are built-up roofs. We are having difficulty getting quality roofing contractors, and we have lots of rooftop units. Any suggestions on the type of roof to look at in the future?
Good question. Oh boy, this is so timely. I'm glad you asked it. This is something that not only us here at Structure Tech have been wrestling with. I think the industry as a whole has been wrestling with this. And built-up roofing, as far as longevity, durability, overall life cycle cost of ownership, a lot of people would agree that's probably as good as it gets. Okay, you've got some really nice single plies out there, and we'll get to this in the second half of the question. But what we're facing now is a diminished workforce. We have a skilled trade community that is not as robust as it once was. We have contractors that are specializing almost exclusively on single-ply roof membranes, and it's hard to get someone out there that can do a solid built-up roof job, and I was at the Ohio State University yesterday doing a big conference and educational type venue, and we spent 35 minutes, discussing this topic, and that's tough. So there still are some great contractors out there to maintain and restore those roofs. I'd say moving forward, Chris, what would be a good application, do you think? I mean, if you're not confident in the built-up community,
I would say it would depend on the climate where you're at, number one, and then there's a white versus black discussion that could be had. But the biggest thing would be, if it's a roof that's 0 to 30, that's we consider poor condition. We'd want to do a complete tear off, and then go back with the system and make sure we incorporate good slope in the insulation, good R value, and just we would always recommend a fully adhered if you can do it. So the choice of single ply, like I said, that's more or less what's the roof used for? Is it a kitchen roof? And does it need good chemical resistance? That's going to drive a certain type of membrane. Is it in a northern climate? That may drive a certain type of membrane. So it really all depends on where your building's located and what it's used for. But like I said, the biggest thing to do is make sure that you're tearing it off, starting from scratch, getting a good drainage design. Then that's going to extend the life of any system you put on there.
And with a district of that size, having as much built up as you have, you really might have some good candidates for restoration there as well. So that's something to think about, because even though you're having problems around the units, those could be reflashed, repaired, come back with a resaturant or emulsion coating, and get some good life out of those roofs yet for a relatively smaller investment. But like Chris said, in a tear-off environment, you'd probably want to look at something like a fully adhered EPDM or PVC single ply.
All right, we only have time for one more question, unfortunately. It is also climate related. Our listener asks, quote, "We are in the desert climate and elastomeric coating is used often. Do you recommend an oil-based or water-based elastomeric coating when applying a re-roof? I got a bid one time that was 3 to 4 times as much because the vendor bid an oil-based material."
I would say, at least with what we deal with, the water-based coatings, like an acrylic, generally you want to have really good slope, whereas more of like a solvent-based coating, it can be a little bit lower slope, and if you have a little bit of ponding, it may be okay. Really, ponding's not good for any type of coating application, but I'd kind of go by that rule of thumb. If it has really good slope, doesn't pond anywhere, then I would probably lean more toward the acrylics. But again, it all comes down to type of roof you're putting on, type of substrate too. I mean, if you're going over a single ply, there's certain formulations, and there's a lot of different coating systems out there. I think there's a new one that's a silicone coating, but again, you got to be careful what you're sticking it to. I would be hesitant to say something like a PVC, for example. You'd want to be really selective on what kind of coating you use, because a lot of things don't stick to a PVC.
And that's a great point. A lot of amazing coatings out there that can serve your roof systems well. But it's a hot thing in the industry right now, so everyone's getting into the coating manufacturer game. I mean, we talked about these different venues. I've been to trade shows, and some 10 years ago you'd have 4 coating manufacturers at this trade show, major roofing trade shows. Last year you go and there's 50 manufacturers with different formulations, different blends. So it's our recommendation, and Chris gave a good answer, but you really want to look at tried and proven technologies and systems. You don't want to be the manufacturer's test dummy. So we recommend that as a building owner and facilities manager, you don't put anything on your building that has less than a 10-year tried and proven track record in the industry, and that can give you some confidence on what the fix is. but that's really good.
All right, that's a very good point to end on. I'm afraid we're out of time. We'd like to thank our audience for a set of very good questions. We're sorry we couldn't get to all of them, although we got to most. If you do have questions, feel free to send them in, and we will try to get them an answer for you from our two experts. And we'd like to thank Nick and Christopher for a very informative presentation today, very useful and engaging, and a set of really instructive photos to assist. I will now close the webcast.
Thank you so much. We really enjoyed it, and I hope everyone got a lot out of it. Thank you so much.